Hello, I'd like to walk you through our poster at this year's Visual Inspection Forum. And we were talking we were presenting our streamlined implementation of the USP 1790 lifecycle. It all starts with some rejects that you classify and trend. And classifying and trending could be the black and white background as well as an inverted microscope. All in all, if it's just a black and white background, it takes you about 1 to 5 minutes to characterize one reject. If you use the inverted microscope, you might spend 10 to 20 minutes for that operation. And then you can populate or create and update a defect library accordingly. If it is something atypical that you see, that triggers an investigation. And now here the real streamlined approach is that you isolate the particle by means of filtration. So it's usually the filtrate what we were using here, and so that takes you, let's say, 10 to 15 minutes, including cleaning the glassware. And then you have the particle isolated on the filter, put it into the instrument, and you can apply Raman and LIBS accordingly. And you get a nice high quality picture. So with the LIBS, you get the chemical elements, or you use the Raman that takes you maybe 60 seconds for one particle, and then you have a chemical identification with the molecular structure. And if you do so, we have here a few examples like our glass, our hair, and the cellulose that we isolated from rejects, and they represent typical groups of rejects, so glass-like, hair-like, or cellulose or fiber type of particles. And here you see the Raman. Raman tells you very quickly that it's cellulose, or in this case keratin from the hair, or glass. And LIBS is very useful for inorganics like glass, and here you see immediate glass response. Now that's already streamlined because it takes you for a reject like a couple of minutes for the classification and trending. And now what you can also see when you would like to streamline is when you go into these subcycles, like when you look into the quality, what you get from your suppliers, for example, for the API or for other container closure systems. Now, what you can also see when you would like to streamline is when you go into these subcycles, like when you look into the quality, what you get from your suppliers, for example, for the API or for other container closure systems. And when you look at that, you have here, for example, the API. And what you see here, that these are particles isolated from an API sample. And we were able to filter that API. We took 1 gram of API, and you see that we find a fairly amount of cellulose particles. We found some graphite, larger 50 micron. And then also in the subvisible range, you find some particles. Well, since this measurement is fully automated, you already save a lot of time in doing this. And if you ask yourself, what is a typical source of cellulose in my production, you might also take a look into the API, even if it's filtered before you fill it. And we also found one large particle in the API. And that's its chemical signature with the ATR, for example. Another rich source of particles, and something that you might want to control in your life cycle, subcycle, is stoppers. In this case, it's not a stopper, but it's a piston for a prefilled syringe. And so in this example, we looked at 25 stoppers. We put them into 200 milliliters with some SDS. This is the filter we looked at. So here particles appear darker than the bright background. and these are the numbers we got from those filters, from those stoppers. So in this case, it was just some polyamide between 25 and 50 micron. Nothing really harmful coming from those stoppers. Another very popular thing at the moment is the ISO 16232. It's a method to remove particulates from bags or from other kind of handling equipment, or also from syringes. And this is an example from a prefilled syringe that we looked at, some calcium carbonate and some other stuff like so the dolomate, which is also some form of calcium carbonate, which has contaminated those. 2 cellulose fibers, 1 glass particle, and some polystyrene with titanium dioxide. That's maybe related to the nest these syringes come in. Overall, we showed you a streamlined approach to implement the USP 1790's lifecycle, and we thank you for your attention.